Good evening, student. In this lecture, I will tell you how will you calculate without doing actual division whether a rational number has non-terminating decimal representation or terminating decimal representation. You know terminating decimal representation and non-terminating decimal representation. For example, I am taking 7 upon 5. Okay. When you divide 7 by 5, you will get 1.4. Means after one decimal place, we get the remainder 0. So this is the terminating decimal representation. This is the terminating decimal representation. Now if I am taking, suppose 10 upon 3. When I divide 10 by 3, 3 3s are 9. 10 minus 9 1, then we'll take 0, then 3 3s are 9, again 3 3s are 9. Now this division will never end. You know this thing. It means 10 upon 3, 10 upon 3 is 3.333 up to so on 3.3 bar. So this decimal representation is non-terminating. So, but to find whether the decimal representation of this is non-terminating and the decimal representation of this number is terminating, I am doing the division. But without doing division, how can you tell whether this is non-terminating or terminating? You can see 7 upon 5. When you divide 7 by 5, you will get 1.4. When you divide by 13 by 8, you will get 1.625. Okay. When you divide 9 by 20, you will get 0.45. When you divide 11 by 2, 5.5. 8 by 5, 1.5. So you can see these all are terminating decimal. These are terminating decimal. Okay. This terminate after one decimal. This are after 3 decimal places. Means at this place, when you divide by 5, the remainder will come 0. (11 upon 2 is 5.5. 8 upon 5 is 1.5. So these are all terminating decimal. But in 7 upon 3, this is 2.3333 equal to 2.3 bar. So this is non-terminating decimals. This is non-terminating decimal. This is again, when you divide 7 by 6, you will get 1.16666 equal to, or you can say 1.16 bar. When divide by 8 by 15, you will get 0.533 equal to 0.53 bar. Okay, these are all non-terminating decimal. But how can you check? How can you tell without doing the division that whether these are terminating decimal or non-terminating decimal? To check it, there is a simple trick. You have to check the denominator number. You have to check only the denominator number of all the rational number. Check only denominator. If the denominator of any rational number is in the form of 2 and 5 product, okay, you can see the denominator of 7.5 is 5. Its denominator is 5. And denominator of this number is 8. 8 means 2 into 2 into 2. The denominator of this 9 upon 20 is 20. 20 can be written as 2, 2, 5. This is the prime factorization of 20. And this denominator is 2. So you can see the denominator of all these number is either 5, either 2, either 5, either 2, or product of 2 and 5. If the denominator is either 2, either 5, or product of 2 and 5, then it is always terminating decimals. But if the denominator of any number, for example 7 upon 3, denominator is 3. Okay, and here 7 upon 6 denominator is 2 and 3, and in 8 upon 15 denominator is 3 and 5. So There is 5 but not 2. There is 2 but not 5. There is only 3. What I want to say, the denominator must contain either 2 or 5 or 2 and 5 both. But other than 2, there should be no number. There should be no number other than 2 and 5 in the prime factorization of the denominator. Here you can say 3 is there. This should not be there. Here you can see 3 is there. This should not be there. If in the prime factorization of denominator there is other number other than 2 and 5, then this the decimal representation of that number is non-terminating. For example, I am taking 7 upon 30. Check the 30. What is the prime factorization of 30? 2, 3 is 6, 5 is 30. 2 and 5 are there. But due to this, the decimal representation of 7 upon 30 is non-terminating. For example, 10 upon 21. 21 is 3 into 7. Here both numbers are different. So this is again non-terminating decimal. Okay. But if I take 7 upon 10, 7 upon 10, 10 is 2 into 5. This is terminating. You know 7 upon 10 is 0.7. Now I am telling you a very important concept. Now this is 15 upon 6. Now if you see 6 is 2 into 3. The rule which I have told you, according to that rule, this should have terminating and non-terminating. This should be non-terminating. But this is terminating decimal. This is terminating. You can see 15 divided by 6. 6 2 is 12. 5 minus 2 3. 6 5 is 30. So decimal representation of this is 2.5. Okay. Now which contradicts our rule? Because according to our rule here is 3. So due to this 3, this must have non-terminating decimal, but we have terminating. Why is it so? Because there is a problem in this question that we are not cancelling out the common factor. If you can cancel out 3 2 is 6, 3 5 is 15. This will comes out to be 5 by 2 and this will come out to be 2.5. So keep this thing in your mind, beta. Ki you have to, if there is any common factor, first cancel out that factor, then check it. Otherwise you will be confused. Okay. So this is terminating decimal, not non-terminating decimal. Okay. So this is how you can tell whether the given rational number has terminating decimal or non-terminating decimals. Now with this lecture I have completed the first chapter. Now I am giving you the homework from the whole chapter. Your homework for the whole chapter is from the work exercise 1.1. You have to do these questions. Question 1 all parts. Question number 3 in exercise 1.2 you have to do question number 1 all part, question number 2 all part, question number 3 all part, question number 4, 5, 6 and 7. From exercise 1.3 you have to do question number 2 and question number 3 all parts and exercise 1.4 full, which I have already done. Okay, so this is the homework for you. Thank you very much.